Start.
Good morning, children. Welcome to Maths B Coordinate Geometry, Chapter 2, Transmission of Axis, Recapitulation Session. I would like to recapitulate the Maths B Transmission of Axis presented by our Pochampad. Dear children, yesterday math has discussed the transmission of axis refers to change of axis. Transformation means change. Change in what? Change in the axis, plural, that is in the coordinate axis. This change takes place in three different forms. The first form is named as transformation of axis. Second form named as rotation of axis. Third form named as translation and rotation of axis. Ma'am has also discussed that translation of axis is change of coordinate axis without changing the direction of the coordinate axis. So x-axis will be same as x-axis, same direction, and y-axis direction is same as the new y-axis direction, but there will be a change in the position of origin. O0, 0 will not be O now. Some other point will come again in the plane. Then rotation of axis is the change of axis where x-axis and y-axis are in the same way, and origin O0, 0 as we construct in general way. But in this kind of change, we rotate the coordinate axis through some angle. For example, x-axis is like this. This will be rotated. This will be moved. Imagine the seconds hand in the watch, minutes hand in the watch, hours hand in the watch. How it rotates? It will be fixed in the middle point, but it will be rotated. For example, the x-axis has moved down, moved forward in this direction with some angle theta. The new x-axis is OH dash. With the same angle, y-axis will also be different. The y dash will be our new coordinate axis. Y dash is new axis. This trace and coordinate axis are the new coordinate axis. Since they moved with the same angle, again the new coordinate axis will also be perpendicular. This is just shifting the origin, but no change in the direction of the coordinate axis. Here, origin is fixed, but the direction of the coordinate axis have changed through the same angle. The combination of the translation of axis and the rotation of axis, as the name suggests, takes both the shift of the origin and then rotation of the coordinate. That means origin is shifted from 0, 0 to some other point x, k. This is our original x-axis. This is our transformed x. Let us denote that with O. And this is our original y-axis. And now this is our transformed axis. Observe children, there is a shift in the position of the origin. So 0, 0 to 0 dash h, k, there is a shift in the position of the origin, as well as there is a change in the direction of the coordinate axis. So it is a combination of both translation and rotation of axis. Out of these three transformations, today we are going to talk about the translation of axis. So we have three transformations in the coordinate axis. One is the translation of axis, other is rotation of axis, and the third one is the combination of the first two changes, which is translation and rotation of axis. The translation of axis is the change in the coordinate axis without changing the direction of the coordinate axis, but there will be a shift in the position of the origin. This is x-axis, this is origin, this is y-axis. Suppose we are shifting from length, O dash is a point. And now we are shifting origin from 0, comma 0 to O dash x, comma k. But this OX is parallel to OX dash, then its direction is maintained. And OY is parallel to OY dash. These two are perpendicular, these two are also perpendicular. So these are all coordinates. This is also a coordinate axis. Now, any pair of perpendicular lines in the plane can be taken as coordinate axis. Any coordinate axis. I can also construct another coordinate axis here. So any pair of perpendicular lines in the plane can be considered as the coordinate axis. Here, O dash h comma k is the origin with reference to the new coordinate system, whereas O0 comma k is the origin with reference to the old system. Let us see the view with a point Px. Children, the coordinates of a point, are nothing but the perpendicular distances of the point from x-axis and the y-axis. Isn't it? How do we get P1, comma 2? The x coordinate of the point is the perpendicular distance from y-axis. How do we get the coordinates of a point P1, comma 2? P1, comma 2 in one x coordinate is the perpendicular distance of the point from y-axis. And what is this 2? The perpendicular distance of the point from x-axis. So the coordinates of the points are nothing but the perpendicular distances from coordinate axis. So when we change the coordinate axis from one place to the other place, please observe an important change. Small b x comma y, the perpendicular distance from x-axis gives its y coordinate. This is y. Now, this perpendicular distance, that is the perpendicular distance from y-axis, gives us x coordinate. When we are changing the coordinate axis, now it is our new coordinate axis. Now, the perpendicular distance of this point with reference to new coordinate axis is only this much. Now, with reference to the new system, the perpendicular distance of this point from y-axis is only this much. Can you find the difference from this length to this length? There is a change in the length from here to here and this. So, when length changes, then the perpendicular distance of the point from the coordinate axis changes. That change correspondingly gives the change in the coordinates of the point. Suppose if we are taking this as the perpendicular distance of the point from y-axis will give us its coordinate, and the perpendicular distance of the point from y-axis, the perpendicular distance of P from x-axis will give us y coordinate. Therefore, P is capital X, comma capital Y. So why the coordinates are changing? Because the distances of the point P from the coordinate axis is changing. Is the point number 1 to be noted. How do they change? They change with respect to the distances that we are adding. What is this distance? X and this distance. Therefore, yesterday we observed small x is equal to capital X plus x and small y is equal to capital X. Okay. Small x is equal to capital X plus x and small y is equal to capital Y. Or if you are denoting this as x dash plus P.Usha said x dash, it will be x dash plus h and y dash plus k. Let us observe one important point here. Small x comma y is a point P. O0 comma 0 is origin. So we are changing O0 comma 0 to O dash x comma k. When we are changing origin from O to O dash, the coordinates of the P are changing. How do they change? P capital X comma capital Y common x dash comma y dash. So this is with reference to the original system. This is with reference to the original system, or old system. And this is with reference to the new system, a transformed system. Then what are the relations? Small x is equal to capital X plus H or x dash plus H. Small y is equal to capital Y dash plus H, Y dash plus H. And the two important relations that man has derived yesterday, in order to find out one of the values if other two are provided. Suppose when origin is shifted to 0, 0, 2, O dash 1, 2, find how P 8, 5 changes. What is the question? Origin is shifted. When origin is shifted, we have to mind that it is the translation of axis. When origin is shifted, the shifted origin will be represented as x, k. What is the shifted origin of 1, 2? Though it is not mentioned in the question, you should understand that 1, 2 is x, k. Therefore, in the formula x will be 1 and k will be 2. So, by reading the text in the question, you should understand out of these three values, only two will be provided. Which two values are provided in the question? The origin is shifted to 1, 2. That sentence means that 1, 2 is a shifted origin. As per theory, shifted origin is 1, 2 is denoted by x, k. Therefore, on top of 1, in the textbook, as soon as you read the question, you have to write 1, 2. And wherever you read the question, indicate x, k as 1, 2. Now, how the coordinates of P transform or find the coordinates of P in the new system. That means new coordinates we have to find. So, what are the given coordinates? All the coordinates. If P is asking us to find the coordinates of P with respect to the new system, what are the P coordinates given then? They are old points or the coordinates of the point with reference to the old system. When it is with reference to the old system, we have to identify small x, small y. Just to substitute, small x is equal to x dash plus x, small y is equal to y dash plus k. What is small x now? It is equal to x dash, I don't know, plus h is 1. Which gives us x dash is equal to 8 minus 1, 7. And small y is 5. Is equal to y dash. How much is the y dash? I don't know. Because I need to find the coordinates of P in the transform. The transform I don't know. K, the shifted origin y coordinate. Therefore, y dash is equal to 2. Transforming 2 with respect to addition on other side. So, x dash, comma, y dash. X dash, comma, y dash is equal to 7, comma, 3. So, 8, comma, 5, how is this changing? 7, comma, 3. So, in the question, we have to understand what is given, what we need to find. Is one kind of the question. In the first, see, in this pattern, we have three kinds of questions. One small x, small y, and h, comma, k will be provided. Small x, small y, and h, comma, k will be provided. And we have to find out small x, small y, and capital X, capital Y are given. We have to find, sorry, small x, small y, h, comma, k are given. We have to find out capital X, comma, capital Y. In the second, we will be given capital X, capital Y, and h, comma, k. We have to find small x, comma. That means the transformed coordinates of the point given, or the points with reference to the new system will be given, and the shifted origin will be given. We have to find out the old coordinates. The third pattern question is the new coordinates will be given, the old coordinates of the point will be given. 1, 2 is changed as 7, 3. So as to change 1, 2 to 7, 3, find the point which origin is to be shifted. Like that we can ask. We have dealt with the first kind. That is all the coordinates we know, small x, y as 8, 5, and shifted origin is given as 1, 2. We got what is capital X dash, capital Y dash. Now I will focus on the second kind of the problem. What is second kind of the problem? We get x, capital X, y. second problem. P 7 comma 3 is okay, transformed point. Is a transformed point when origin is shifted. When origin is shifted to when origin is shifted. When origin is shifted. When origin is shifted to which point? To 1 comma 2. Find the coordinates. Find the coordinates of P in the original system, in the old system, or which is next to the old system. Read the question, children. See, reading the question and understanding the data is very, very important. In maths, especially in coordinate geometry, your command over the language is very, very important. Read the question. Let us understand what is given. Given that P 7, 3 is a transformed point. One point is changed as 7, 3. Because it is a transformed point, H dash is 7 and Y dash is equal to 3. Is this clear? When origin is shifted to 1, 2, 1, 2 is a shifted origin. Shifted origin x coordinate is fixed and its y coordinate is fixed. And we need to find the coordinates of P in the old system. Old system is small x comma y. So we have to find what is small x comma y. We have a formula. Small x is equal to capital X plus h. Small y is equal to capital Y plus. Don't learn too many formulas. What is x dash is equal to y dash is equal to h is equal to. Don't take tension. Learn only two formulas. X is equal to x dash plus h. Y is equal to y dash plus k. Just to substitute the given values, unknown will come automatically. You need not learn 3, 4 sets of formulas. It is learn only small x is equal to capital X dash plus h. Small y is equal to y dash plus k. Known values, just to substitute here, unknown will come automatically. Is this clear, children? Now, what is small x dash plus h? What is x dash, children? 7. And what is h? 1. So, what is 7 plus 1 now? What is 7 plus 1? 8. Y is equal to y dash plus k. What is y dash, children? 3. Plus what is k? 2. 3 plus 2 is 5. Therefore, small x comma y are the coordinates of the point in the old system are 8 comma 5. The same point that we got in our previous example. Is it clear? This is second one. So, old points will be given. New points will be given. That is, coordinates of the new point will be given. Shifted origin is also provided. Now we need to find out the coordinates of the point with respect to old system. This is model number 2. Third model is small x comma small y, capital X comma capital Y. The coordinates of the point in both the systems. The coordinates of the point in the both the systems, old system and new system will be given. We have to find the point 0, 0 to be shifted to which point, so that our point, our point 7, 3, so that our point 7, 3 will be changed as 8, 5. 7, 3 will be changed as 8, 5. That we will find out. So in the question, first we got to find out what is given. Seven comma 3 is when the origin is shifted from 0, 0 to some point x, k. The coordinates of the point P 7, 3 changed as 8, 5 is the text. The 7, 3 is changed as 8, 5. It is a change the coordinates of the point, or the coordinates of the point reference to the older system, or original coordinates of the point. These are the different terminologies that will come across in the first. Now, what are the formulas? The same formula for any kind of function that they are asking. Translation of axis. Small x is equal to x dash plus x, small y is equal to y dash plus. I don't write any other formula, only these two formulas. Here, I will substitute what are given there. What is small x children? Small x is 7. Is equal to x dash is 8 plus x. From which we will get x is equal to 7 minus 8 minus 1. And what is k? What is h comma k? K is y minus r. I just substitute in the relation of y. What is y? 3. Is equal to what is y dash? Y dash is r. That's implies k is equal to 3 minus 5 minus. Okay? So this is a point where R needs to be shifted, so I have to find the coordinates of the point. This is the recapitulation of yesterday's class. Over to Usha ma'am to find out the equation. Change in equations are the given change in equation that will find the transform original equation. Thank you, Usha ma'am.
Thank you, ma'am. Thank you, Suhasini ma'am, for recapitulating the concepts which I have taught yesterday. Today we are going to deal with how a translated equation can be found, or an original equation can be found. So just see the problem. When the origin is shifted to 3, 4 by the translation of axis, let us find the transformed equation of 2x square plus 4xy plus y square is equals to 2. Here we need to understand what are given. Here they have given the shifted origin, that is h comma k, that is 3 comma 4, and what they have given, they have also given the transformed equation. We need to find the transformed equation. They have given the original equation. So they have given what? H comma k, that is 3 comma 4, and they have also given the original equation 2x square plus 4xy plus 5y square is equals to 0. Now, on substituting x is equals to x dash plus h, we know the formula, and y is equals to y dash plus y dash plus k. We know the formula, that by substituting h comma k here in this formula, we will get x is equals to x dash plus 3 and y is equals to y dash plus 4. In the original equation, we will get the equation of the transformed system, that is 2 times of, in this system we are just substituting these points. In place of x we are substituting x dash plus 3, while in place of y we are substituting y dash plus 4. That is 2 times of x dash plus 3 whole square plus 4 times of, in place of x we are substituting x dash plus 3, and in place of y we are substituting what? Y dash plus 4, plus 5 times of y dash plus 4 whole square is equals to 0. Next, x here we have x square plus 3, it is in the form of a plus b whole square. So what is the expansion form of a plus b whole square? We know that it is a square plus 2ab plus b square. Here we are just doing that. That is 2 times of x dash plus 3 whole square can be written as x dash square plus 6 dash plus 9 plus 4 times of, we are just multiplying these two, that is x dash into y is nothing but x dash y dash plus x dash into 4 is nothing but 4x dash plus 3 into y dash is nothing but 3 times of y dash plus 3 times of 4 is nothing but 12. In the similar way, if we have y dash plus 4 whole square, we already discussed that it is in the form of a plus b whole square. So this can be written as a square plus 2ab plus b square. Therefore, 5 times of y dash square plus 8y dash plus 16. So next step is we need to multiply this 2 inside, 4 inside as well as 5 inside. So next step we'll get as 2 times of x dash square can be written as 2 plus 2 times of 6 is 12 into x dash square plus 2 times of 9 is 18 plus 4 times of x dash y dash plus 4 times of 4 x dash is nothing but 16 x dash plus 4 times of 3 y dash is equals to 12 y dash plus 4 times of 12 is nothing but 48 plus 5 times of y dash square is equals to 5 y dash square plus 5 times of 8 y dash is equals to 40 y dash. 5 times of 16 is equals to 80. Now we are just arranging it. So 2x dash square plus 4x dash y dash plus 5y dash square, and we are adding x dash. Here we have 2x dash 12x dash plus 16x dash is equals to how much? 28x dash. And in the similar way, we have 12y dash plus 40y dash is equals to 52y dash. Plus adding all the constants will get how much? 18 plus 48 plus 80 will gives us 146. This is nothing but the transformed equation for the given axis. But by dropping the dashes, we'll write it in a simple form. That is 2x square plus 4xy plus y square plus 28x plus 52y plus 146 is equals to 0. Next, in this, what are given? The point to which the origin is shifted and the transformed equation are given below. We need to find the original axis. So what are they have given? They have given the shifted origin as well as they have given what? A transformed equation. This is a transformed equation. So we need to find the original equation. So here h comma k is equals to how much? 3 comma minus 4. And here they have given the transformed equation. We know that the coordinates of the transform equation is x dash y dash. Just simply I have substituted that x dash square plus y dash square is equals to 4. We need to find what? The original system. In place of x dash, we need to substitute x minus 3, and in place of y dash, we are substituting y minus 4 is nothing but y plus 4 in the given transformed equation. Therefore, we'll get the original equation as, that is x minus 3. In place of x dash, I'm substituting x minus 3 whole square. In place of y dash, I'm substituting y plus 4 whole square. That is equals to how much? 4. Now, simplifying it, it is in the x minus 3 is in the form of what? A minus b whole square. That is nothing but a square minus 2ab plus b square. That is x square minus 6x plus 9 plus y plus 4 whole square can be written as y square plus 8y plus 16. That is equals to 4. Now rearranging x square plus y square minus 6x plus 8y plus 9 plus 16 is 25 minus 4 is equals to 0, and we'll get the original equation as x square plus y square minus 6x plus 8y plus 21 is equals to 0. You need to try these problems which are in your textbook. That is, when the origin is shifted by a transformed equation, by the translation of axis, find the transformed equations of the following. They have given origin is shifted means they have given the value of h comma k, as well as they have given what they are asking us to find transformed equation. That means which axis they which equation they have given. They have given the original equation. These are the original equations, and you need to substitute the points there for the to get the transformed equation. The point to which the origin is shifted and the transformed equations are given. Here also they have given what h comma k as well as the transformed equation. We need to find the original equation. Just substitute in this, we will get the answer, original equation. Find the point to which the origin is to be shifted by the translation of axis so as to remove the first degree terms from the equation. They have given this equation. They are asking to find what the origin is to be shifted. That is h comma k they are asking us to find. But in this equation, as we have h, I am considering that h comma the shifted origin as alpha comma beta. Let the origin be shifted to alpha comma beta by the translation of axis. Now, in place of x, we have x dash plus alpha, and in place of y, we need to substitute what? Y dash plus beta. On substituting these values in the given equation, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0, that is a into, in place of x, what we are substituting? X dash plus alpha whole square. In place of plus 2h into x dash plus alpha into y dash plus beta plus b into y dash plus beta whole square plus 2g into x dash plus alpha plus 2f into y dash plus beta plus c is equals to 0. Here we need to simplify it. That is a into, it is in the form of a plus b whole square. So we are writing x dash square plus 2x dash into alpha plus alpha square plus 2h into, we are just multiplying these two terms, that is x dash into y dash is x dash y dash, and x dash into beta is equals to x dash beta plus y dash into alpha is y dash alpha plus alpha into beta is alpha beta plus b into y dash plus beta whole square. This can be written as y dash square plus 2y dash beta plus beta square plus, we are just multiplying this inside, that is 2g into x dash plus 2g alpha plus 2g into y dash plus 2f y dash plus 2f beta plus c is equals to 0. Now we are multiplying this, the terms which are outside the brackets inside. That is, by rearranging the terms of the above equation, we'll get what? A into x dash square plus 2h into x dash y dash plus b into y dash square plus, we are just taking the first degree equation, then 2 into x dash into a alpha plus h beta plus g, and 2 into y dash into h alpha plus beta plus g, and a alpha square plus 2h alpha beta plus b beta square plus 2g alpha plus 2f beta plus c is equals to 0. Here what they have given that we need to remove the first degree equation. Here the first degree terms are where, here we have the first degree terms, that is 2x dash into a alpha plus h beta plus g, and 2y dash into h alpha plus beta plus g. To remove that equation, we need to equate these two into 0. So we are taking this as equation 1, and we are equating this. To remove this first degree terms, we are equating these to 0. That is, a alpha plus h beta plus g is equals to 0, and h alpha plus b beta plus f is equals to 0. And by solving these two equations, we are solving the equation 2 and equation 3. We'll get what? We are solving for that alpha, beta and 1 we need to take, and we need to take here we need to consider the coefficients of beta, that is h and b. Here we need to consider the constant terms, that is g and f, and we need to consider the co coefficients of alpha, that is a and h, and again we need to consider the coefficients of beta, that is h into h and b. Now we need to find alpha, beta and one value. How we will take the values, we'll just see. Alpha can be found out by h into alpha minus b into g by ab minus h square. In the similar way, beta can be found by gh minus af by ab minus h square. Therefore, we can get the origin can be shifted to this point, that is alpha comma beta, that is hf minus bg by ab minus h square, and gh minus af by ab minus h square. This result can also be used as a formula too. Next is find the point to which the origin is to be shifted by the translation of axis so as to remove the first degree equation. In this here they have not given in this term in the previous problem we have ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0, but in this equation 2hxy term is not present. 2hxy term is not present, so we are taking xy term as we don't have any xy term. We are substituting h is equals to 0 in the previous formula. Then we'll get h in this formula, that is hf minus bg by ab minus h square and gh minus af by ab minus h square. In this, if we substitute h is equals to 0, we get the required point as minus g by a comma minus f by b. That is the required formula. Now you can try this at your home. This is given in your exercise. Find the point to which the origin is to be shifted so as to remove the first degree terms from the equation. So you need to use that formula, that is minus g by a comma minus f by b. As we don't have any xy term in this equation, just simply use that formula. You will get the answer for this. So hope you all have understood what I have said. This is nothing but yesterday we have discussed the coordinates. Today we have discussed how the equations can be framed, how can we found the equations of a transformed equation as well as the original equation if the shifted origin is given. Thank you.